Hello everyone, this is Kao Yu and today I will be teaching you about AP Physics C Mechanics. And today's topic is on Newton's law. It's one of Newton's law and it's a typical AP Physics C problem where a skydiver is falling with an initial speed and she opens her parachute and her speed decreases to the terminal speed so that she can land safely on the ground. And the air resistance provides a force of kV, which is proportional to her current speed at which she is falling. So for this question, let me solve some problems related to this. So for A, so we need to draw a free body diagram for A. As you know, there is mg acting downwards because she's falling downwards right now, and there's air resistance which is kV acting opposite to the direction of mg. Since speed is decreasing, because the whole purpose of using a parachute is to decrease her speed so that she approaches a terminal speed that she can land safely on the ground. That means that kV must be bigger than mg. This also means that the length of kV in the free body diagram must be longer than the length of mg. Okay, let me go on with B then. We need to write acceleration in terms of the variables written there. So as you know, net force is given as mg minus kv, and net force is ma, and this is mg minus kv. So A is just mg minus kv over m, which is g minus k over mv. And this is negative, which means that acceleration is acting upwards. It makes sense because since she's falling and she's falling down, and if the acceleration acts upward, then she has to slow down. Okay, then let me go on with C here. So let's calculate the skydiver's terminal speed. So the definition of terminal speed is her eventual constant speed of descent. This means that net force is 0, and net force is mg minus kv. Since net force is 0, net force is equal to mg minus kv, so mg minus kv is 0. In here, I'll just denote this as Vt because Vt represents terminal speed in most cases. So mg is kVt, Vt is mg over k. Okay, then let's do D. So we have to sketch a graph of V versus T. So, before we do that, we know that the initial speed is V naught, and the terminal speed, which is denoted as Vt, is equal to mg over k, right? And of course, V naught is bigger than Vt because the speed is decreasing here. And acceleration is given as g minus k over m times v, and this is less than 0. So the magnitude of the acceleration is written like this, and this is, of course, can be written like this. So this represents the magnitude of acceleration. So using this information, let's draw the v versus time graph. So let's say at time t equals 0, initial speed is v naught, and eventually you approach the terminal speed, which is mg over k. Before we draw it on the graph, we need to notice that slope of v versus t graph is acceleration, as you know, because if you differentiate v with respect to t, you get acceleration, and since slope of v versus t graph is a, since a is negative here, the slope has to be negative, and the magnitude of slope has to decrease as time increases. Okay, so using these three information, let's draw a graph here. So the slope has to be negative, and the magnitude of the slope has to decrease as time increases. So you have to draw it like this. It makes sense because, as you can see, the slope is negative here, and the magnitude of the slope, which is steepness, is decreasing. As you can see here. So it first starts like this, and then at here it looks like this. So the magnitude decreases as time increases. So it can be drawn like this. Okay, so we did up to D, and let's solve E. So for this one, we know that net force is mg minus kv, and net force is ma, of course. And I just told you that A is dv dt because if you differentiate velocity with respect to time, you get acceleration. So A is just dv dt. This is a differential equation, and you can solve it using separation of variables, like this. So what I did was I collected all the v terms on the left side and the other terms on the right side. And if you integrate both sides like this, then you get ln absolute value of mg minus kv, and you have to multiply the constant term, which is minus 1 over k here, and then it looks like this. And if you multiply by minus k on the both sides, you get instead of writing as minus kc, I'll just write as c1 because minus kc is also a constant, so you can just write like this. And I told you that mg minus kv is negative because kv is bigger than 0. Kv is bigger than mg, so this can be written like this. So if you take out the absolute value sign over in ln x, you get kv minus mg because kv is bigger than mg. So it can be written like this, and this is equivalent to this. this one actually, this is equivalent to e to the power of c1 times e to the power of minus k over mt. But instead of writing like this, because e to the power of c1 is also a constant, you can just write it as this. And you have to solve for v here. So kv is just mg plus c2 e to the power minus k over mt. mv is just mg over k plus, instead of writing as c2 over k, I'll just write as c3 e to the power of k over mt. Okay, so let's use the initial condition to get c3. When t is equal to 0, v is equal to v naught. Therefore, v naught is equal to mg over k plus c3 e to the power of 0. And e to the power of 0 is 1, so v naught is equal to mg plus k plus c3. So c3 is just mg over k minus v naught. Therefore, the final answer for this question is mg over k plus mg over k minus v naught. This is the final answer. Then let's solve f. So we already calculated the terminal speed, and terminal speed is given like this here. But let's calculate terminal speed using the expression here. Actually, the terminal speed is expressed like this actually. Terminal speed Vt is equal to so it's the speed of Vt when t goes to infinity. So let's calculate that. So let's calculate this expression. And when t goes to infinity, Vt becomes mg over k plus mg over k minus v naught. And this term, the e term becomes 0 because as t goes to infinity, e to the power of minus k over mt becomes 0. So this just becomes mg over k. So as you can see, the terminal speed that we got here is mg over k, which is same as the terminal speed we got in C. So the answer is consistent. This is it for today, and I'll be going on with next topic in the next class. Thank you.